So the first thing that we are going to do is get the source code and run it on a single node to make sure that everything works correctly. So I'm going to clone the repo. So git clone, git // github.com, jpetazzo orchestration workshop. And now if I go in orchestration workshop, I can see that this is exactly the repo I was showing you on GitHub before, obviously. And if I go to the dockercoins directory, I see my 4 services, the compose file. And we are going to start the application. So generally speaking, when you see a repo with the compose file at docker-compose.yaml, you know that all you have to do is docker compose up. It's a kind of automatic thing. You just like when you have a make file, you can do make, or when you have like a configure script, you do like .configure make install, or when you have a vagrant file, you can do vagrant up, and so on and so on. When you have docker compose.yaml, you know that you can do docker compose up. And when you do that, it will parse the YAML file and say, okay, so I have to build all those services. So for each service, it's going to go in that directory, it's going to find the Docker file, and it's going to build that Docker file. And so I had like one service, the worker is in Python, then this is Hasher, it's in Ruby, using Sinatra and Fin. At some point, the Redis image was also pulled. That's the part that if we were to do that straight from the Lisa build network, we might have to wait a long time because this is pulling like maybe a couple of 100 megabytes between the base images and the packages. And there is also a Node.js component, that's the web interface. We decided to use 3 different languages and frameworks and everything. It's not necessarily a good idea, but the reason why I did that is first to illustrate that, yeah, in microservices, you can pick whatever you want and mix and match and it works. And also educational value, because I didn't want to have like a pure Python app and then somebody who doesn't know Python is like, oh, that doesn't interest me. Or have something in Ruby and then it's the other way around and so on and so on. So that way there should be at least one component that you can tamper with if you want. So this that we're seeing scrolling now, that's the logs of all our containers. So in the beginning, there is the name of the container and then the line of log. Okay, so those logs are pretty verbose. There is a bunch of HTTP logs from the web services, Hasher and RNG, because they are getting like hammered with requests. And then once in a while, there is the worker service. I'm going to scroll lock. The worker service tells us I've done 4 loops, 4 units of work, and I'm updating the hash counter, and so on and so on. Okay. So this is pretty verbose and not super exciting, so I'm going to interrupt it by hitting Ctrl-C. When I hit Ctrl-C, I'm sending a kind of polite way to say, hey, please stop. And here we have 2 well-behaved services, Hasher and Redis. They stopped immediately. And then 3 not so well-behaved services, WebUI, RNG, and Worker. You could see that it took them like 10 seconds to stop. It's not that it took them 10 seconds to stop. It's that those services were not very well implemented, and they are just ignoring signals. So Docker is sending them a term signal, but they're like, I don't care. And 10 seconds later, Docker is like, okay, I told you to stop, so now I'm sending you the kill signal, and you have no choice, and you must terminate. It's kind of traditional sysadmin thing. Like, first we try to shut down things gracefully so that they can like close files nicely, flush data and everything. And after a timeout, if they're still running, we kill them. So I'm mentioning that because this 10-second thing for those services will be a kind of recurring theme, because each time we will need to restart or upgrade or whatever those specific services, we will see that thing kick in. And that's deliberate, by the way. I could have fixed that by now, you can imagine, but that's pretty important to see that in action. So now I'm going to restart the application, but I'm going to put that in the background. So it's almost the same command, docker compose up, but I add the -d flag. So that works just like with docker run. Docker run -d lets you put a container in the background. Docker compose up -d lets you put the whole app in the background. And then I can do docker compose ps. And Docker Compose PS is a little bit similar to Docker PS, except instead of giving you like all the information about all the containers, it will give us only the containers for this application, and it will give us a kind of subset of the information. In that case, the thing that is interesting to me is the web UI. I want to have a look at this application, and I see that the web UI here is exposed on port 8000. So if I connect to my Node 1 virtual machine on port 8000, I should see the web UI. All right, let's have a look. So I'm going to put the IP address of my machine, port 8000, and yeah, that's the web UI. And we can see that we're doing about 4 hashes per second. Okay, fine. Now that the app is running in the background, we can check the logs with Docker Compose logs. If I do that, it will blast all the logs to me, so that's a bunch of logs. There is a slightly better way. You can do like --tail1, which means just show me the last line of log of each service, and then --follow, which is the equivalent of tail-f. So in that case, the logs will continue to stream to me a little bit like before. The key difference is that now if I hit Control-C, I'm just stopping tailing the logs. I'm not stopping the containers. They are still running now. All right, this is a little note for people upgrading for Compose 1.6. In Compose 1.6, when you do Docker Compose logs, it will continue to stream the logs to you. This changed in 1.7, but that's like a while ago in Docker timeline. So if we look at the UI, as I said, it looks like it's doing about 4-ish hashes per second, and sometimes there are spikes. The spikes are not like our virtual machine suddenly getting busy and going faster or whatever. It's just because I'm not a front-end developer, and I coded this with all the skills I could muster, and that was not much. So basically, this is measuring speed by looking at the number of hashes and computing the delta between successive measurements and putting that on the graph. And so this is like, it's not asking to the system what's the speed, it's asking how many hashes do you have, and then it's asking again and again and again and computing the delta. And so you just add network latency and browser latency and JavaScriptness and stuff. So that's why sometimes you have a little glitch like the spike here or this weird thing here. It's all my fault. And also, the actual speed is not 4 hashes per second. It's more like 3.3333333. But if we look closely, we will see that it's doing 4440, 4440, 4440, something like that. And so if you average, it will be 3.33333. But this is because the counter is not increasing smoothly. It's increasing once per second. Each second, the worker is updating the counter by how many loops it's done so far. And so when you look at the different values of the counter, instead of doing like 1, 3, 7, 10, 12, whatever, it's doing like 0, 4, 8, 8, 12, 16, 20, 20, 24, 28, 32, 32, something like that. And so once in a while, it looks like it hasn't made any progress because between the 2 successive looks given by the UI, the counter hasn't been increased. TLDR, don't give me a front-end project.